Okay guys, so sorry it's taken some time. Hopefully these videos will be very useful for you. Remember that your test is going to be this coming Wednesday. So first thing we're going to do is, as you can see, this worksheet is where I'm going to pull a couple of problems from. I'm going to entitle this video Ratio and Proportions, and then as I go to the next few worksheets that are in the week 4 folder, I will title it as the name of the worksheet so that you know where these problems are. All right, so we're going to jump into it. I'm going to go ahead and minimize this and open up the whiteboard. 1 second. All right, so here we go. So what we're looking at is going to be ratio and proportions. So again, this is ratios and proportions. And I'm just going to jump around, okay, for these problems that are on this worksheet. So let's look at number 1. So for number 1, it says they want a unit rate, and I'm going to read it. It says, write as a unit rate 350 miles. So when you have a unit rate, what that means is it's almost like a fraction. So let me, before I jump into number 1, I'm just going to say that a unit rate is like a fraction. Okay, there will be one type of variable or a piece of information in the numerator and some more information in the denominator. So if we look at number 1, it says 350 miles, so 350 mi for miles on 10 gallons of gas. So the order that you're receiving it, 10 gallons, okay, of gas, is the order that it needs to be. The information that comes first is the numerator, and the information that comes second is the denominator. So let's just imagine. So imagine that we're driving down the road, we put 10 gallons of gas in our car, we achieve 350 miles for every 10 gallons of gas. So the way unit rates work is you always want to put them with respect to 1 in the denominator. So let me kind of write a note here. So unit rate has to have a 1 in the denominator. Okay. Sorry, denominator. Okay, so basically what we're going to do is just divide. Okay, we're going to divide, and we're going to see, you know, how many miles can be achieved on just 1 gallon of gas. Okay, so bear with me because I'm new to using this particular whiteboard. I'm going to just kind of clear everything out and start from scratch. Yes. Okay, so again, back to the problem. So we have 350 miles of distance has been achieved for 10 gallons of gas. So what we want to do is get a 1 at the bottom. So if we do 350 being divided by 10, we would say, of course, 10 goes into 35 3 times. We would multiply for 30, subtract, we would get a 5, bring down, and then, of course, 5 goes into 50, and then we would have no remainder. Okay, so basically what we've just achieved is that 35 miles of distance can be covered on 1 gallon of gas. Okay. Of course, the other trick that I showed you guys with zeros is if you have a pair of zeros, you could have just slashed them out here, and as you can see, it's 35 and there's miles per gallon. So again, unit rates have to do with putting something with respect to 1. Okay, and so in this case, our car, you know, can go 35 miles for 1 gallon. Okay, that's number 1. The answer is 35 mi over 1g. Okay, now let's move on. I'm going to jump to I'm just going to jump around to what I think would be interesting. So let's look at number 2. It says find fraction notation for the ratio. So now let's talk about ratios. So ratios, okay, is, of course, you know, you have something in the numerator over something in the denominator. So again, it looks like a fraction. So it says find fraction notation for the ratio 3 7/8. And you see that word 2, 6 1/4. So the information that came first is our numerator. So I'm going to put that 3 7/8 at the top of my fraction. And I'm going to put 6 1/4 at the bottom. Notice in the directions it says don't simplify, which again, all fractions should be simplified. That's our rule of thumb as math teachers, but we'll just go with it. So we got 3 7/8, 6 1/4. Again, none of this information I can do with the way it's presented, so let's change both of these into mixed fractions. So remember, for this, and I'm going to write it a little bit better, write it kind of stacked on top of each other, like this, so you can see it better. So we're going to take this whole number piece, multiply down to the denominator, and then add up. So 3 times 8 is 24. 24 plus 7 is 31 over 8. Here I have 6 times 4 is 24. 24 plus 1, 25 over 4. Okay, so now I've changed both of those into improper fractions. And so remember, this is back to that keep, change, flip, because I have a fraction being divided by another fraction. So what this becomes is 31 over 8. And when I bring this fraction up, I'm going to change division to multiplication. That's the change. And then I'm going to do the reciprocal flip, that second fraction. So here's where we are. Okay? So now I cannot simplify or reduce this way. The 31 because it's prime. I can't find a number that goes into both of these, but I can reduce these two numbers. So 4 goes in here 1 time. 4 goes in there 2 times. So now where I'm at is I have 31 times 1, which is 31, over, and then I have 2 times 25, which is 50. Okay? So as you can see, the fraction notation of those two numbers creates this ratio of 31 over 50, and 31 is a prime number, so you can't simplify it or break it down. And then 50, you know, you can't reduce, or you can reduce 50, but again, this is a prime number in the numerator. So this is the answer for number 2. Again, it's 31 over 50. Okay. All right, so now let's move to another problem. Okay, so I'm going to jump around. Let's look at number 4. Okay, number 4. In the rectangle shown, so let's draw the rectangle. In the rectangle shown, I'll make that as neat as possible. What is the ratio of the length to the width? So remember, the information they gave us here is 215. For the width, they gave us 129. Okay. The side that goes from left to right, the horizontal side, that's our L, the length. The side that goes up and down is the width. So there's the length and here's the width. Okay. And again, notice how you have to read very carefully. It says they want the ratio of length to width. So that's the order. So we're going to say the thing that's going to get with the colon to the left side is the 215. The width is 129. Okay, and so they said, again, what is the ratio of length to width, of width to length? So they also want, so they want to and, they want W to L. Now, we know that 215 is divisible by 5. 6, 7, 8. Try to think of other numbers that are divisible by, but we know 5 can go into here. But the beauty of this is that 129 is a prime number, so we can't reduce this. So the first part of the question, 2 answers, ratio of length to width. This is the answer right here. 215, put a colon, 129. And for this answer over here, it's width to length. So we're just going to flip it and put 129 to 215. Sorry about that. So 2. Okay. So you can't reduce it or simplify it. Usually you're supposed to, because again, this 129 is prime, so there's no number that goes in there and also goes into 215. So this is the answer for number 4. Done. Okay. Hopefully that makes sense to everybody. Okay, so I'm going to jump around now, and I'm going to try. Just looking. Let's look at number 9. And I have to think of something for proportional. Can't think of it at all, actually. Okay, so for number 9, determine whether two pairs of numbers are proportional. So the numbers, so we want proportionality here. Oops, sorry. I'll do that again. Click the button. So we want proportionality. So to tell if something is proportional, I just drew a blank. But let me write the numbers down real quick. Whether the two pairs, so the pairs they're giving you are 5 and 1/5, okay, with the 6, or is 2 and 3/4 proportional with 7 and 1/2. Okay, so we're going to look at these two numbers and these two. Okay, let me do something real quick. I'm going to show you, just if you were at home by yourself, how to go about learning some things on our own. So I'm going to open up the internet for a second, and I'm going to type in proportional. Proportional relationship, and there's a formula. That's why I couldn't recall. So if I go to images real quick, it should be something like y is equal to xn is what I wanted to. So I don't see it coming up. So this is what formula. Oh, there it is. Yeah, I'm going to show it to you guys because I'm seeing it. Piece of it. Oh, why didn't they show it to me a little bit later? Okay, sorry about that. So let's look right here. So the piece of it is here, right here. Y equals kx. That's the formula. And then that's to show that something is directly proportional to one another. So I'm going to just shrink this down, go back to here, and that's the formula I'm looking for. So again, to say that something is proportional, it has to have this kind of relationship. Y is equal to k. X. All right. So we don't know what k is. K is always a constant. It's some number. Constant. It's a number that you can multiply by your independent variable, like your x, and then y is the output. All right. So if I look at these two numbers, we got to first figure out what k is. So we're just gonna, again, I don't know which one's x and which one's y right now, but we're just gonna try it out. So let's say that our y is 6. I don't know what k is, and then I have 5 and 1/5. That's my x. Okay. So the way to solve for k, but first let's change our mixed number into a improper fraction. So we're going to multiply down 25 plus 1. So we would get 26 over 5 times k, and we're saying that equals to 6. Okay. So we want to solve for this number here, k. So remember, we're going to divide, because we have multiplication happening with this 26 over 5 times k. So I'm going to divide by 26 over 5 to both sides. What you do to one side, do to the other. So one more time. Because k is being multiplied by 26 over 5, I have to do the opposite operation of multiplication, which is division. Okay. So now these two numbers will cancel out. Okay. K will be by itself. And now I can solve for it, because again, I have 6, which will put that over 1. That's like the key change flip. We're changing division to multiplication, and we're going to split that 5 over 26. Okay, cannot reduce this way, so let's reduce this way. 2 goes into 6 3 times. 2 goes into 26 13 times. So the final answer to this now, if we multiply across, 3 times 5 is 15 over 13. Okay. So that's what we're saying k is, would be the relationship if these two numbers were proportional. But the question is saying determine the two pairs of numbers are proportional. So when we solve for k for this number, we got 15 over 13, all right? And now I'm going to do the same thing on this one and see if I get 15 over 13. Now remember, I let this one be my y, this one be my x, okay? And now I'm going to let the 7 halves be my y, and this will be my x. And if I get that 15 over 13 again, then these two pairs are proportional. Okay, hopefully that makes sense. So far, I'm going to delete the screen, clear it out, and what we're looking for again is our k was 15 over 13, but we still need to evaluate this pair here, the 2 and 3/4 with the 7 and 1/2. Okay, so this is my y, and this is my x. Okay, sorry about that. All right, so here we go. So let's put 7 and 1/2 equals, I don't know what k is, and my x is going to be the 2 and 3/4. Okay. All right, so again, change this to both of these actually, into improper fractions. So I get 7 and 1/2 will become 7 times 2 is 14, plus 1 is 15. So I got 15 over 2 equals k. And then multiply this, 2 times 4 is 8, 8 plus 3 is 11 over 4. Okay. And again, I'm solving for k. So again, this is multiplication. So 11/4 times k, we're doing multiplication. So to get k by itself, I have to do division to both sides. What I do to one side, I do to the other. So now these two numbers are gone, and now we have k will be by itself on this side, and we're going to do that keep, change, flip. So we have 15 over 2. We have another fraction, so we're going to change to multiplication and flip 4 over 11. All right. So in this case, as you can see, we can't reduce this way, but we can reduce this way. 2 goes into 1 one time, 2 goes in there 2 times. So now what I notice is I have 30 over 11 as my k, okay, which is not the same as 15 over 13. So these two numbers are not proportional, okay, because you should get the same k constant. So the answer to number 9 is no, they're not proportional. And again, if I come up with something or ask me this in class, because I will be looking at that one, I'm just doing it off the top of my head. All right, so let's jump around to 2 more off of this page on the front, and then I'll grab 2 more from the back, and then I'll let you guys try them out on your own and then ask questions on Monday. All right, so let's talk about proportions. So let's look at number 11 on the worksheet. So as you can see for number 11, it says solve, and it has 31 over 186 equals 14 over m. Okay, so we want to figure out what this m is. And again, when there's an equal sign separating these two fractions, this is a proportion. This is what a proportion looks like. And so when you're going to solve for proportions, you always have to cross multiply. Cross multiply the numbers. Then the second step is then divide. So I'm going to show you how that looks. Okay, so give me 1 second. I'm going to switch over colors. All right, so now, if you're going to cross multiply, you're going to cross multiply this way. Then you drop this down. Sorry, that's super thick. I didn't expect it to do that. And so the way that looks, okay, so 31 times m. So we're going to get 31. Oh my goodness. Sorry. I'm just understanding how to get my pen to just be normal. All right, here we go. Okay. we're going to cross multiply. So 31m, because we have to cross multiply, you have to put this equal sign, and then you're going to cross multiply this way, and then you drop your answer down on the other side. So we'll do the scratch work. So 186 times 14. 4 times 6 is 24. This is 32 plus 2 is 34. 4 plus 3 is 7. Then we'll put 0 to hold our place. 1 times 6. 1 times 8. And then 1 times 1. Then we'll add this together. 4 and 10. 15, 16. And then a 2. So we get 2,604 when we cross multiply the 14 times 186. Hopefully my math is good. So after you cross multiply in both directions, now you're going to, I forgot the E here, sorry guys, divide. So we're going to divide by whatever the coefficient or number is in front of the letter. So divide by 31, which you do to one side, do to the other side, 31. Now M will be by itself. And now we do T-bow. Right? Top in, bottom is out. So now I come over here and do 2,604 is going to be divided by 31. And we know that 31 can go into 260, but the question is how many times. So I'm going to go here real quick. I'm just going to erase the scratch work. So let's figure out how many times can 31 go into 260. Okay. Okay, so I'm going to try 31 times, let's remember, like 6 or 7. Let's try 7. So 7 times 1 is 7, and then as you can see we get 217. Let's try 8. So let's add to this another 31, see if we can get closer. So we get 248, we're getting closer. And if we add one more 31, I think we will overshoot it, which will be 9, then 7, 2, which is too much. So 31 goes into here 8 times. So put that right over the 0. It came out to being 248. Do our subtraction. Borrow from those 6. Make this a 10. So we get a 2 here, a 1, and then bring down the 4. And then our next question is, how many times can 31 go into 124? And I'm thinking we should do 4. Yeah, 4 works. I can see it. So we'll put a 4 right here. We've multiplied 31 times 4, and yes, we will get 124. No remainder. Done. So the answer to this is M must be 84 to make these two fractions be equivalent and equal to each other. So 31 over 186 is the same as 14 over 84. So that's how you do proportions. Okay, I hope that makes sense to everybody. Cross, multiply, and divide. All right, let's do one more of those. Clear the screen on. Okay, so now, what if I have fractions though? So let's look now at number 12. Okay, number 12. All right, so now, what if I have, this is number 12, what if I have 1/6 over 1/2 equals, then I have 1/2 here, and then this x I'm looking for, okay? So for this one, all I'm going to do is, we're not going to make it complicated, okay? Now I could just cross multiply like this and get, 1/4, and then we could do it that way. Let's do that. Let's stay consistent. So we're going to cross multiply this way, drop it down, so we would get 1/6 x, multiply them together. Put your equal sign. Now we're going to cross multiply this way and drop it down. So I'm just going to tell you 1/2 times 1/2 is 1/4. Numerator times numerator over denominator times denominator. So when we multiply this is 1/4. Now, if I want to get rid of this 1/6, anytime there's a fraction, you just multiply by the reciprocal. So multiply by the flip of that fraction. So the reciprocal of 1/6 is the same as 6/1. So I'm going to come to this side and do 6/1. Okay. So as you can see, 1 times 6 is 6. And then, so let me just show you how that looks. 6/6 times 1 is 6, which of course 6 divided by 6 is 1. So that's why x will be by itself, because it's just a 1x. And then over here, 6 times 1 is 6/4. Okay, so the final answer to this is x must be, okay, 6/4, which you can reduce that if you divide by 2 to the bottom and top to as 3/2. So in other words, 1/6 divided by 1/2 is equal to 1/2 divided by 3/2. That's what will make these two sides equal. So the answer to number 12 is right here, 3/2 for number 12. Okay, now I'm going to flip the back side of this over. I don't know how much more time I have left in my recording. But I'm going to go on the back side and just do a couple of really quick some word problems. So let's look at number 17. Number 17. Do two or three on this back side and call it a day. So on a test of 18 items. So I know that the test, you should read very carefully with word problems. The test has 18 questions or items. So that's what I'm telling myself in my mind. On a test of 18 items. Charles got 15 correct. So he got 15 right or correct. And it asks, what is the ratio of the incorrect to the correct? So he has 18 questions total on this test, right? He got 15 right, which should subtract. So we're going to do 18 minus 15, which will leave me with 3. So he missed 3. So these are the number of 3 incorrect. He got 3 incorrect. Sorry, that's an E. Incorrect. And then, of course, he got 15 right. So again, the ratio that they want, you always look at order, is the incorrect first. Then you put a colon for your ratio, and they want the correct on the right side of the colon. So we're going to put 3 to 15. That's the answer, 3 to 15. So let me also, if you were to simplify this, because this is almost like having, not almost, it is like having a fraction. So you have 3/15. Again, this is the wrong to the right, which you guys know it would reduce to 1/5. So let me explain what this simplified fraction means. It means every time that he answered a question on this test, he would get 1 wrong and 5 right. Again, he would get 1 wrong, then he would turn around and get 5 correct or right on this 18-item test. Okay, so once you simplify this fraction, again, wrongs to right, he would get 1 wrong and 5 right. And he would keep doing that until the test was all done, and hence the fact that he would get 15 right and he got 3 wrong, which is a good grade. Okay, so that's number 17. All right, now let's go to, I want to look at number 19, I guess. Yeah, let's look at 19 because it's pretty wordy, and then I'll end with 16, and you try the rest. Okay? All right. To control a fever, a doctor suggests that a child who weighs 28 kilograms. So we have this child. Okay, they weigh 28 kilograms as their mass. 28 kilograms be given only. So a kid that's this much, he can take up to 320 milligrams of Tylenol. Okay. And it says if the dosage is proportional to the child's weight, okay, which means that for ever so much mass that this child has, he'll get this equal dosage of, or this consistent, constant dosage of Tylenol. That's what that means. Replay that again if you don't understand what I mean. But, you know, every time he's another 15 kilograms of mass or 18 kilograms of mass, he will get the same constant amount of Tylenol. So I'm going to read the question again. If the dosage is proportional, remember proportional is this right here, y equals kx, that K is the constant that's proportional every time he's so much mass, okay? Okay, it says, if the dosage is proportional to the child's weight, how much Tylenol is recommended for a child who is 35 kilograms? So we know for 28, you give them 320. So how much can we give them, if they're 35 kilograms in mass, how much can they take of Tylenol? So as you can see, proportionality helps you. So we know that when a child weighs 28 kg, they will take 320 milligrams of Tylenol. So the cool thing about, just to show you proportions and doing these setups, is you always want to be consistent. So up here, as you can see, is the mass of the kid, mass of child. Now on the bottom is the information with the Tylenol. So on the other side of our fraction, we must put the same pieces of information. So we want to figure out if a child is 35 kilograms, how much Tylenol do they take? So this is a proportion, and we're going to do the cross multiply and divide. So we're going to cross multiply this way, drop it down. We get 28 times x, so 28x. We put our big equal sign. We're going to cross multiply the values this way, drop it down. I'm going to do some scratch work over here. So I got 320 times the 35. Okay, in my first row I get 0, and I get 5 times 2 is 10, carry the 1, and then I get 16 here. 0 to hold my place. 3 times 0 is 0. 3 times 2 is 6. 3 times 3 is 9, and then I add this up. 0, 0, that's 12, and then 9, 10, 11. Okay, so that's what I have here on this side. 11,200. Okay, and again, I'm trying to solve for how much Tylenol to give this kid that weighs 35 kilograms. So I cross multiply. The second step is to divide by whatever number is in front of x. So we're going to divide by 28 over here. We're going to divide by 28 over here. And again, I'm not sure if this is getting cut off. So I'm going to clear this out real quick and see if I can remember my numbers. So let's just go here. So we have 11,200 was equal to 28x. Divide by 28. Divide by 28. This is a 1, so x is now by itself. That will give me the amount of Tylenol. And I'm going to do T-both, top in, bottom out. So I'm going to come over here and put 11,200 being divided by 28. So I know that I'm going to try 28 going into 112. So what number should I try? Let's try, I'm going to come over here. 28 times 4. I'm going to try 5. No, I'm not going to do 4. I think I'll overshoot it. No, let me try 4. Okay, 8 times 4 is 32. 2 carried 3. I hit it right on the money. 4 times 2 is 8. 8 plus 3 is 11. There it is. So this goes in there right over the 2. 4 times, as you can see, it gives me 112. When I subtract, I get 0. I bring a 0 down. 28 goes into 0. 0 times. I would multiply for 0. Get 0, putting down a 0, and so it would be 400. Okay? That's the answer. So if a child weighs 35 kilograms of mass, you're to give them only 400 milligrams of Tylenol. There we go. So I hope that would make sense. That was number 19. Last one. So I think I don't know how long this video is going to be here. Okay, last one. Let's look at number 16. In the rectangles below, so we have this smaller rectangle. Sorry if these are not too pretty. We have in the rectangles below, the ratio of length to width is the same. So this one is 4 feet for the width, 6 feet for the length. We don't know the length of this one, and 10 feet is the width of this one. So again, we have another proportion. So we're going to put length information on the top, width information on the bottom. And again, it doesn't matter if you would put W up here or L up here, as long as you're consistent with your setup. So we're going to put the length of the smaller rectangle here on the top, which is 6 feet. Sorry, On the bottom is 4 feet. And then for the bigger one, we don't know the length of the larger one. And then down here, we're going to put 10. So again, we're going to cross multiply and divide. So we'll cross multiply this way. We'll get 4x. Cross multiply the other way here. Sorry, jumped ahead of myself. 60. Divide by 4 to both sides. So x is equal to, we do the T-bow. Do the T-bow. And I think I know the answer to this one. I think it's 15. So then 1 time for 4, yeah. 2, bring down 0, yes. Okay, 4 times 5 is 20. No remainder. Okay, so the answer to this is 15. So for these two rectangles to have or be proportional to each other, because it says the ratio of length to width is the same, find the length of the larger. Okay, so this right here is 15 because look, 6 over 4 is equal to, remember the length information is at the top. So I'm going to put 15 over, 15 over, what was it, 10. And if you reduce both sides, okay, if you divide that by 2, you get 3. You divide this by 2, you get 2. Over here on this one, if you divide the top by 5, you would get a 3. You divide by 5 to the bottom of this, and you get a 2. As you can see, look, 3 halves is equal to 3 halves. So that x has to be 15. So the answer here is 15. Okay. So this concludes the video. I hope it was helpful. I know that there are probably a lot more problems that you guys want me to do, but in the same regard, I want you just to take your time, read the problems very carefully, try your best, and then we will convene on Monday, and then I will answer questions for you. All right, this was a long video. All right, see you guys later.